Good afternoon, class. So we will just first show the solution, exercise or example left unanswered due to lack of time. This is on indeterminate forms. What are indeterminate forms again? N is a limit said to be an indeterminate form. Anyone? Send your answer to the chat box. What is an indeterminate? In the concept of limits, an indeterminate form is here. Can you send it everyone when you answer so I can see? Okay, the value of the limit can't be determined. If both limits equal to 0, then the ratio of the limits determinate. The values of the limit can't be determined. These are some of the answers given by some of you in the class. Okay, yes, the value of the limit cannot be determined, right? But that is due to the fact that the limit of the numerator equals 0 and the limit of the denominator equals 0. If you are evaluating the limit of our quotient, which is equal to the quotient of the limits, you obtain a 0 over 0. But it doesn't mean, remember, that an indeterminate form is undefined. It is just indeterminate due to its form, but it may or may not exist. So we had several examples of that. I gave already two. Let me just show you one more, this one, which requires the technique of conjugation first before you can actually compute its numerical value. But you have to first make sure it's an indeterminate form, which I did not show here. I did it for the first two examples, but sometimes questions in the quiz or long test may be tricky when answering limits. Sometimes it's not really an indeterminate form. Okay, you may think it's an indeterminate form due to the appearance, but actually when you plug in the number here, you won't get a 0 over 0. But you can check, of course, if you plug in 0 for x here, you'll get 2 minus 2, and you plug in 0 for x here, you get also 0, so 0 over 0. Now, if it's not an indeterminate form, there's no need to apply conjugation. You only apply conjugation if you have a 0 over 0. A 0 over 0 means there is a common factor. But in this case, the common factor is not that evident. So you have to somehow find that common factor by first changing the appearance of the expression, multiplying by the conjugate. So you have this one here, which is just equal to 1. And again, multiplying by 1 does not change the value, but it changes the appearance after simplification. But again, you do not expand that part where you have, okay, well, let me state it this way. You only expand that part or simplify that part where you have the expression, one of the expression in the quotient multiplied to the conjugate or to its conjugate. So you only expand the numerator. Where you have something like a minus b times a plus b, so you know, or you can easily simplify this as a squared minus b squared, leaving this one as a product, the denominator times the denominator. So you square the first term, that's 4 plus x, the radical is removed. You square the second term, which is 2, and minus a squared minus b squared. No need to use the FOIL method here. And then again, leave the other part as a product. Then you simplify the numerator. You can just show this. Okay, what happened here? X squared. Okay, right. So 4 minus 4, 4 cancels out. You're left with an x on the numerator. That means x is the common factor we are really looking for. And that should be evident because the 0 of this factor is 0. To expect x to be the common factor, which should cancel out if the indeterminate form is to exist. So canceling out x, no more 0 over 0. And again, you can cancel x since x is not 0, x is only approaching 0. Of course, you cannot do that if x is 0. 0 over 0 does not cancel out as 1. But if it's not 0, it cancels out as 1. So you're left with just this expression here. So you can now finally obtain the limit by direct substitution. Don't need to apply the limit properties if it's not about that, okay? So plug in 0. Sir, I thought it's only approaching 0. Why did you plug in 0? Well, yes, it's approaching 0, but the limit can be obtained by direct substitution. Okay? So you'll get 1 over 4 as the value of the limit. Any question so far before we move on to the next topic of continuity? Why can't I see it? Think. Can see it in my other gadget, the chat. You can only use direct substitution, Mr. Ku, if you are allowed to do so. Okay, and that also can only be done under certain conditions, as discussed in the previous lectures. Now, teka lang naman, siguro dahil binago ko yung name ko sa kabila, hindi ko makita yung mga chat. Anyway, so continuity from the root continuous. So that is without break or without stop, or rather without disconnection. But how do we define the concept of continuity in mathematics? Well, the layman's term, or rather the, what we call this? Yes, that in layman's terms, you can say that a function is continuous by referring to its graph. If its graph can be drawn without lifting up the pen, right? The whole graph, that is, can start from any point on the graph, arrive to any other point on the graph without lifting up your pen. Now, there are graphs that have parts, right? Like, remember the hyperbola? Y equals 1 over x, for example. The graph of 1 over x is a hyperbola. And there are 2 branches of the hyperbola. So if you get a point from one branch and another point on the other branch, you cannot connect the two, okay, by moving along the graph without lifting up your pen. So it has a discontinuity. But of course, this does not suffice for mathematics. We cannot just, okay, give a definition, right? As long as you can draw the graph without lifting up your pen, then that is continuous. So question now in the quiz: prove that this function is continuous. How do you do that? Do you draw the whole thing, the whole graph? Of course not. So we will actually give a mathematical definition of continuity of a function. And this can only be done using the language or the concept of limits. Remember, limits or the concept of limits is the basis of all calculus. Without the limit, there's no derivative. And so with all other concepts in calculus, actually, right? Limits are like the, what do you call this? The atoms, as in a particle. Okay, they are the basic, what they call this? Structure of calculus, limits. So how do we use limits to define continuity? Now, remember, limits are dynamic. They help us study motion. And since we said you can draw the graph without lifting up the pen, so that means we can use limits to give a definition, a formal definition to the concept of continuity. And before that, we can learn, okay, or we can understand what continuity is by actually understanding or studying what a discontinuous function is, right? Sometimes you can study a thing by looking at its negative. It's not like this, it's not like that. Then you say, it's like this. So first, let's look at what a continuous function is not. So let's look at three kinds of discontinuity. What we have here is a discontinuity which we call a hole in the graph of the function. So if you look at the figure here, you see that A is actually is not a part of a graph. It's an open, or yes, it's an open point or circle, which tells us that there's no point there. What do you mean when there's no point on the graph? It means, okay, mathematically or numerically, the function has no value at that point, at this C, whatever this C is, which may be the origin, which may be any other real value, okay, C. So in other words, if the function is not defined for some point, it does not exist, sometimes that may give rise to a hole in the graph. And you cannot draw the graph of this function without, or yes, you can only draw it by, well, technically not lifting up your pen, but when you reach this point, somehow there's nothing to land on there. Like imagine if this were a manhole and you were walking along this path, you would fall, right? So parang ganon. Kasi hindi siya continuous. Okay, excuse me for a while. Okay, let's continue. So that's one kind of discontinuity. Another, when you have, okay, a break in the graph. Technically, there's a hole also somewhere in the graph, but you can say there's no hole since it's defined anywhere or everywhere. Okay? Halimbawa, pwedeng solid point dito pero open point dito, okay lang yun kasi defined naman siya dito. So, para ring wala talaga siyang hole. So rather, we call this type of a discontinuity a break. Parang kumbaga naputol, no, yung graph. So hindi siya continuous because you cannot draw the graph without lifting up your pen. You get 2 points, a point each, okay? From each part, you cannot connect them without, okay, lifting your pen. So what does this mean mathematically? This means that the limit of the function does not exist. if in the previous kind or type, there's no function value, f of c is not defined, for a break, the limit from the left and the limit from the right at this point c are not equal. So that the two-sided limit itself does not exist. Look at the figure here. If I approach c, let's say this is your c. If you approach c from the left, your function value will end up at this point. Okay, this point here. But if you approach the same number c from the right, your point will end up at this point or this y value here. So you have two different values, so that the limits from the left and right are not equal. Therefore, the limit itself does not exist. And if that is so, there's a break in the graph. Actually, sometimes we call, is that right? Yes. We call that sometimes a jump. Okay. Sometimes depends on the graph. Okay. Hindi lahat kasi ng breaks jumps, no? But all jumps are breaks in the graph. Pag infinity na kasi may asymptote, usually we don't call that a jump at the point of discontinuity. Okay, so again, in this case, the limits from the left and from the right are not equal. Therefore, the limit of the function at c does not exist. And when that is so, it's not continuous there. The third case or third type, an isolated point. So we may say there's still a hole in the graph, but unlike the first case or first type, the function is defined at c. However, it seems that the definition is off, okay, from where it's supposed to be, thus creating a discontinuity in the graph. So to be able to draw the graph, you have to like move your pen up, okay? Point that, okay? Like make a dot your pen, and then lift it up again, go back, then draw the rest of the curve. And what's the difference between this type from the previous two types? Doon sa unang type, f of c is not defined. But here, f of c is defined. In the second type, or second kind of discontinuity, this one does not exist because from the left and from the right, they are not equal. But here, look, if you come from the left, you'll arrive at this point. If you come from the right, you'll still arrive at that point. Not here, right? But here. So actually, this limit exists. Remember, last time I said, even if the function is not defined, actually, supposing this is not here, the limit may still exist. So this kind of discontinuity happens when the limit of f of x as x approaches z is not right where they meet. Okay, it's at some different value. So that means it's not equal to f of c here. This is f of c, but the value of your limit is just right here, not the same. Again, in this case, both f of c and this one, the limit exists, but they are not equal. So let's define using those three discontinuities. We can just negate those what they call this conditions to arrive at a precise definition of a continuous function using the language of limits. So what is a continuous function? Let's read the let me read the definition. A function f is continuous at x equals c if and only if, number one, f of c exists. Remember this one for the first type. If this one does not exist, you create a hole, or there's a hole in the graph. Number two, this must also exist, as in the second type where there's a break because this does not exist. And not only that, thirdly, the limit of f of x as x approaches c not only exists, f of c is not only defined, but moreover, they are equal. Unlike in the third type, where the two are existent, but they are not equal to each other. So if all three conditions are met, then surely the function will have a graph that is continuous. In fact, this is the definition of a continuous function, and we are able to define it using limits, not a layman's way of explaining the concept of continuity, where you use like a pen and a paper, you do not lift your pen, you can draw the graph. So with that, so this seems obvious, we will use, okay, some of the questions may be like this. You are to prove using this definition that a given formula, or rather a given function, is continuous. You do not draw the whole thing and then, sir, there are no breaks. No, that's not a valid proof, okay, or way of proving the continuity of a function. So how do we use this to prove that this function, the parabola x squared, y equals x squared, is continuous at this particular point, the origin? Because when x is 0, y is also 0. That's actually the vertex of the parabola. So what's the first thing? You have to have the function defined at C. Is that so here? Well, yes, there's no problem because it's defined at 0. Okay, it's substitutable, right? Remember, the domain includes all allowable values of x, and 0 is allowable. You are not dividing by 0 here. You're not getting the square root of a negative number. Okay, so that means the function is defined at 0. In fact, it's 0. Second condition, limit of f of x as x approaches c must exist. So let's see that. Does the limit exist? So without resorting to a table where you plug in values from the left and from the right of 0, we will just use what we have learned in properties of limits to arrive at the value of this one. So limit of f of x as x approaches 0, okay, f of x is x squared. Already this should be x approaches 0. And we have already shown, or we have already stated, that our functions actually have limits, or their limits exist, and we can arrive at the value of their limits by direct substitution. So actually, using a table, you can show that the limit from the left is 0, the limit from the right is 0, and therefore the limit itself is 0, and therefore it exists. So condition 2 is satisfied. I hope you're listening, and I hope you're in front of your screen. So I'm not requiring you to open your camera. So that's not enough. The two have to be equal, and obviously they are, but still, for formality's sake, you have to, or get the whole credit, you have to state that the limit of the function, okay, at 0 is the same as the function value at 0. This is direct substitution. This is limit. Remember when we were distinguishing the two, and we hope that we could always just evaluate by direct substitution. So we can state the definition of continuity in another way by saying, oh, a function is continuous if you can get its limit by direct substitution. Kaya nga, pagpunta natin sa ibang module or chapter, you ask, sir, when are we sure that we can obtain the limit of a function by direct substitution? The answer is now simple: when that function is continuous there. In fact, the two are the same thing. Okay, that's the actual meaning of a continuous function. You can obtain its limit by direct substitution. Go back, the third condition. Right? You can get the limit of the function at C by evaluating f at C. Of course, provided the first two exist. Of course, you cannot have the third if the left-hand side does not exist and the right-hand side is not defined or does not exist as well. Okay? Is there any question regarding the meaning of a continuous function? Anyone? Conceptual yan muna, And then ito, example lang ito eh. So sa conceptual muna. Is there any question regarding the concept of continuity? Yung definition mismo? And how about this example? Is it clear how we prove that the function is continuous at 0? So in fact, sir, we can do it for any other point, like 1, 2, 3, -1, or any other real value. Yes, in fact, you can show that for any real number x, not just 0 here, the function is continuous. You just repeat this each time for each real number you're considering. Okay, so suppose the question is at x equals 1, so you do replace all these values by 1, okay, by 1, and you will arrive at all three conditions being satisfied. So we say that the function is continuous everywhere, not just at 0, not just at any particular point, but everywhere or at any real number C. Or continuous, we say the function is continuous on the set of all real numbers or on R. Any question regarding function that is continuous everywhere or on R? Basta lahat, buo, no? Buong real line, tuloy-tuloy yung graph. From negative infinity to positive infinity, if the graph is continuous, we say it is continuous everywhere or on the set of all real numbers. So then we move on to the next example. So let's consider this piecewise defined function. If you look at the split here, actually we just have x not equal to 1 and then otherwise here. Okay, so it's just sort of redefined at x equals 1. Instead of using this formula, you give the value at 1 directly as 1/3 for the simple reason that, okay, if you plug in 1, well, you get a 0/0. So if I want the value to be defined, I just give it a specific number there, x equals 1. So let's show using the definition that this one is a continuous function at x equals 1. Oh, sorry. If, determine if the function is continuous at 1. So f of 1, is it defined? That's the first condition. Yes, it's already given in the definition. It's 1/3. So it's defined, it exists. Condition 1, satisfied. Condition 2, does the limit exist as x approaches 1? Okay, let's see. Now, how do you replace f of x here? Do you replace it with 1/3 or with the upper branch? The upper expression or the lower? Sometimes the lower may not be that simple as a constant. Remember, I gave an example when you use the upper, when you use the lower for a piecewise defined function. Okay, check yung example na yon. Now, since x approaches 1, what can you say about x? Is it equal to 1? See? Yes. No, only approaching. So, not equal to 1, right? If you're approaching a point, or let's say the train is approaching the station, it's not yet at the station. If it's at the station, you no more say it's still approaching the station, right? So it's not 1, just approaching 1. So that means it's not 1. So it's not equal to 1. So we have to use this branch of the definition to replace f of x here. So as seen here. And then we evaluate this limit. It's an indeterminate 1 minus 1 over 1 minus 1, 0/0. So we use conjugation. Is this the conjugate? Okay. Retain this as a product. Expand the numerator, square the first term. Okay. Teka, na-cut ko na, no? So, anyway, there's supposed to be... Okay, ito kasi mag-x minus 1 ito eh. You square the first term, that's x. You square the second term, ano siya? 1. That's x minus 1, which cancels out with this. So, when you expand the numerator, it's just this one here. So, you cancel it out. You're left with just this on the denominator. This is the expression after conjugation and substitution now. Direct substitution. 1/2. So first two conditions are okay. We give them a check, but we see that the value at the first one here is 1/3. The value at the second one is 1/2. They are not equal. So still, we do not have a continuous function. Here's the graph. Okay? Anong klaseng discontinuity yan? What do you call this discontinuities? Okay. Sometimes I look at the names, your last names, so I can take a mental note sino yung participative sa class. Then, minsan the first 3 or 5 that pops up yun. So, if I were to ask you this, suppose you are allowed to change the definition of the function. That you're allowed to change it. What would you do? Or how would you redefine? You're allowed to change this number. What would you put there to make this continuous? Palitan mo yung 1/3 ng kahit anong real number na gusto mo. Ano yung ipapalit mo para continuous siya? Obviously, yes, right? 1/2, yes, 1/2. Tama? And how did you get 1/2? Siyempre, nag-discuss na tayo. You get it by looking at the limit, right? Number 2. Yes, correct. Sir Romualdez. So, when we looked at the second condition and evaluated the actual value of the limit to prove that it exists, we got 1/2. And for the function to be continuous, the definition of the function there at 1 should also be the same as the limit value there. And that would mean graphically that you just move this isolated point over this position. Thus, parang you're closing the gap so that when you walk right over this line here, you won't fall there because it's already continuous. It has to be 1/2. Otherwise, no matter how you define the function at 1, it will always result in an isolated point and thus a discontinuous function. But again, you do not prove it using this graph or by graphing. You have to show one of the conditions is not satisfied. Any question? So we have looked at the continuity at a point and then at all real numbers. If it's continuous for every point or for every real number, we say it's continuous everywhere. Now, what do you mean by a function that is continuous in or on? You can use sometimes those two, what do you call this in English, yung mga in, on, I forgot. When you speak of a position of an object, we call that in English. Prepositions. Prepositions pa rin ba sila? Or mayroong particular kind of a preposition? Kasi may prefix sa prepositions. O yeah, position, ano. Pwede rin. Hindi ako magaling sa English. Actually, I got, what you call this? When okay, matagal na yun, ano, was, kung nangan sabihin, matagal na panahon na yon. Wala pang colored phone noon. Black and white pa lang. Kakalabas pa lang ng mga 3210 noon. Nokia pa ang talagang ano nun. But anyway, my God, I was basic English. Anyway. So what do you mean by a function that is continuous in or on an interval? Doesn't matter. Like in Facebook, sometimes say on Facebook or log in, then some website would write log on. Okay, anyway. Depends on the point of view siguro. Here. What do we mean by that? A function is said to be continuous in a closed interval. What's a closed interval? You include the endpoints. Both endpoints must be included. Pag isa ay excluded, we call it semi-closed or sometimes semi-open. Pareho lang naman yon. So if both are excluded, you call it open. So you call it or you say it to be, you say the function is continuous in a closed interval if it is continuous at every point inside the interval. Kasi yung endpoints lang ang magkakaproblema, di ba? Why? Kasi one directional lang. You can only approach the endpoint from one direction. For example, you can no longer approach, kung putol yung graph, kung walang definition outside, you are not allowed to approach it from the left of A because the domain stops or begins at A. Similarly, if the domain ends at B, you can no longer approach the graph from the right. So we have what we call the concept of right hand and left hand continuity. And I believe, or I think that should be self-explanatory, what you mean by left hand continuity and right hand continuity. So for example, sir, I remember continuous function has condition 2, which states that the limit must exist. Therefore, the left hand limit and the right hand limit must be equal. How about at A? There's only one one-sided limit to consider. Then if that limit exists, we say that it's left hand continuous, or rather, sorry, kapag kaliwa kasi ito, di ba, manggagaling sa kanan, so right hand continuous at A. Similarly, you can only approach B from the left, but there's nothing from the right. But if the limit exists there, okay, at siyempre, equal dun sa function value, yung third condition na hindi lang nag-i-exist. Kailangan equal siya sa value ng function sa endpoint na yun. So we say that it is left-hand continuous at B. Anyway, let's look at some figures here. There. So let's state the intervals where the function is continuous. First, at negative infinity to -4. There's no problem with all the points to the left of -4 because you have two-sided, or rather, you can approach any point there from two directions and you see there's no break, there's no hole, there's no isolated point. But once you consider the right endpoint here of this interval, okay, huwag nyo munang titignan yung iba, okay, hindi ka pwedeng mag-approach, di ba? Rather, if you consider the whole graph, pag nag-approach ka from the right, iba yung value if you approach it from the left. And you might say, oh, it's discontinuous there. You're right. But it's right hand, or rather, left hand continuous here, if you are only considering this interval. Are we clear? So we still say that the function is continuous at this interval. Okay, considered, okay, apart from the rest. Okay. Why? Because it's left hand continuous. Sir, bakit sinama si negative 4? Kasi di ba iba yung limit from the left, iba yung limit from the right. Because we're only considering continuity in, that siguro in nga, continuity in an interval. The rest is outside, right? That interval. And then negative 4, 0, inopen natin sa negative 4 at 0. Why? Bakit naka-open si negative 4? Hindi ba continuous naman? Pag right hand continuous siya, sir, sa negative 4, tapos left hand continuous siya sa 0. Tama ba ako doon? Yes. Tama. Kasi considered in itself, or rather, yes, in an interval kasi, forgetting about the other parts of the graph, talagang magkakaroon ng hole kung ang titignan lang natin yung negative 4, 0. But actually, wala kasi siyang meaning, di ba? Kailangan defined yung function doon. Pero in this interval, walang definition yung function dito. Although meron siya dito sa interval na negative infinity, negative 4. So it's not left hand, or rather, it's not right hand continuous here kasi pagdating mo doon, there's a hole. It's not left hand continuous at 0 because there, you do not have a point also. There's a hole there also. So we just say it's continuous at the open interval negative 4, 0. Because at any other point, you can approach the graph or the point from both directions. And there's no hole or break or isolated point there. Magpapareho yung limit from the left, limit from the right, and then equal dun sa mismong value ng function. Now, can you tell me another interval of continuity? Can you give the next part here? Okay, closed interval 0, 4. And how about the next? For infinity, for 8, open, yes, for 8, open. And then last one. Or the last one. Yes, open at 8, then infinity. So what kind of a discontinuity now, considering the graph as a whole now, what kind of discontinuity do you have at 8? What kind? A hole? Yes, a break. More particular, yes, it's a break. How about at 4? What kind of discontinuity do you have? A 4. Break then. Yes, break as well. But in particular, we can say there's sort of a jump. Gusto ko sana ipakita kung bakit ito hindi tinuturing na jump. When you try to draw the graph, okay, from the left of 8 and try to connect the two portions here from the left of 8 or to the left of 8 and to the right of 8, you cannot draw it without, of course, lifting up your pen. But once you lift up your pen, where do you start, right? Kasi may asymptote dito eh. So we really call this a break now, but this one, you can lift it up, but you know where to put it, right? So it's like it jumped. Ito infinite yung gap eh. So it's not technically a jump. It's a break, a jump, a jump, a jump. We do not call this a hole when you are considering the whole graph now, the whole domain. Magiging hole yan kung may hole din dito. And the function is not defined. We can say there's also a hole at 8, and at the same time, there's also a break. Kasi walang definition sa 8. You see that? It's defined at negative 4, di ba? What is the value at negative 4? You can see, you can count those marks there. So it's defined at 4. Nalilito na, ha? It's defined at 4. Ano yung f of 4? F of negative 4, sorry. Po ba yun? Bilangin nga mabuti. Po ba yun? 3, yes. 1, 2, 3. So defined siya. So it's not a whole. May takip, parang hirap i-ano, no? Baka malito kayo. As long as it's defined, we do not call it a whole. Now, if there's another hole there, then definitely we both have a hole and a break at the graph or at that point of view. How about at 0? What's f of 0? Estimate na lang. F of 0 is 1/2. Yes, 0.5. Ito, yung 0, nandito, hindi dito 1.5 to. Butas dyan eh. Dito siya, 0.5. How about f of 4? F of 4? 0.5, pareho. Siyempre, hindi ko nilagay, no? Pero kung i-estimate mo lang, parang nasa gitna, 0.5. F of 8. F of 8. Is it really 0? No. F of 8, undefined. Yes. Dito kasi, ano na to eh, asymptote to eh. And then dito, considered as in itself whole. So, walang value sa 8. Hindi kasama sa domain yung 8. 4 is in the domain, 0 is in the domain, negative 4 is in the domain, but not a 8. Anyway, I hope we're clear with the meaning of continuity in an interval. Now let's go to properties of continuity. So we're trying to finish all the things you need to study on before the first long test. Marami pa hanggang module 3 ito. So as much as I would like to just do this rather, what do you call this? Slowly and in parts pa sana, more examples, more difficult examples. I might not be at a liberty to do so due to the time pressure. And that is why this is both asynchronous and an asynchronous class. Now, as mentioned in the syllabus, by the way, pinost ko na ito sa Canvas. Kung napansin nyo, last 2 years ago yata yun or summer yata yun. No? Last summer yun eh. Nagturo kasi ako nito. So yun na lang. Minsan, pinopost ko na yon so you can study in advance and sometimes, if needed, or if I cannot teach you online, then at least you can study the lesson asynchronously. And as mentioned in the syllabus, once a material is posted, I am not obligated. Actually, hindi ko naman ano yun it is all the teachers that agreed on that. All materials posted in the syllabus will not be discussed. But actually sa akin naman, I may or may not opt to discuss those materials. So I could have already started with the derivative this session. Pero conceptual pa kasi ito. Sa Math 21 ko last semester halimbawa, wala akong ginawang ganito. Wala akong lesson na discuss. Puro problem solving talaga kami. As most of the teachers did also. So sila yung mag-aaral ng concepts. And then, when they come to class, dapat alam na nila yung concept. Ako, magsasagot na lang ako ng items sa book, no? Exercises. So, mga mahihirap yung nasasagot namin. Kasi nga, hindi na kailangan mag-discuss ng lesson. But here, if I discuss the lesson pa, ang tinatawag na the tip of my tongue, Pros and cons kasi wala yung... Anyway, merong, kumbaga, nawawala. No? So yun yung disadvantage naman. Hindi tayo makapag-discuss ng maraming exercises, lalo na yung mga mahirap. So let's go to properties of continuity. So dito, usually mag-list tayo ng mga functions na continuous para pagdating na natin sa chapter 2 or module 2, hindi na tayo gagamit ng limits. Direct substitution na tayo lagi. And as I have mentioned, you can use direct substitution when evaluating a limit if the function, if and only if the function is continuous at that point. So what are some of the continuous functions on the set of all real numbers? Isa na dyan, syempre, yung constant function. It's continuous everywhere. Pag sinabing constant function, the graph is horizontal. It's constant. It does not change in y. So you obtain a horizontal line, a continuous, infinite horizontal line for the graph of f of x equals c. And already stated, no? A polynomial function is continuous on all real numbers, on R. Everywhere, continuous siya. But not a rational function using the concept of continuity in an interval. A rational function is continuous almost everywhere or on the set of all real numbers except where its denominator is 0. Now, how about radicals of functions? Like square root, cube root of a function. Well, it depends on the index. Alam natin, if you have an even index, you cannot have a negative inside. It will not be a real number. So if n is odd, no problem. The cube root, the fifth, and so on, root of a function is always continuous wherever f of x, or whenever f of x is continuous, this also is continuous. So continuous siya wherever f of x is continuous. In other words, f of x and the nth root of f of x have the same set of continuity. Kung saan continuous yung isa, doon din continuous yung isa. Provided odd index. Not if even, kailangan non-negative yung loob. Okay? Pag sinabing non-negative, pwede yung 0. 0 is neither positive nor negative. So, non-negative ang 0 pwede. Let's illustrate. Determine where the following functions are continuous. F of x equals x over x squared minus 1. What kind of a function is this? Is it a polynomial function? If not, what kind? Rational, because it's a ratio of two polynomials. So a rational function is continuous everywhere except where the denominator is 0. So you just find the zeros of the denominator, in other words. Not equal to 0, the denominator. So x not equal to plus minus 1. Ito yung zeros ng denominator. So not equal. This involves a radical of a polynomial function. Index is odd, so no problem. Wherever the one inside is continuous, the whole thing itself is also continuous. What is the thing inside? The function inside is a polynomial, quadratic in particular. And it's a polynomial, and a polynomial is continuous everywhere. So what's the set of continuity of G? All real numbers, everywhere. Okay, again, x squared minus 4 is continuous on R since it is a polynomial. The index of the radical is odd, therefore G is also continuous on the same set. One more. Fourth root of x plus 6. This time, even index. We know that the function inside the radical is continuous on all real numbers, since again, it's a polynomial function, linear polynomial. But due to the index being even, we have to restrict to values of x greater than or equal to 0. And solving for x, you get simply x greater than or equal to -6. This now is the set of points where it is continuous. H is continuous on or in the interval -6 to infinity, including -6. Is there any question? Puro definition lang yan. Continuity at a point, continuity at an interval or in an interval. Then yun nga, we enumerated kinds of functions that are continuous almost everywhere and everywhere. Who has a question before we move on to infinite limits? Kung wala, does anybody have an idea of what an infinite limit is? Can you define to me an infinite limit? We have finite limits. So what is an infinite limit? Yes, let's see. Somebody tried. There's an asymptote. Well, yes, that's the consequence of having an infinite limit, but sometimes there may not be an asymptote. Limits whose values are not finite. Yes, or infinite. So when the limit value, siyempre undefined na yon, hindi siya finite. But if the limit is infinite in value, we call it an infinite limit. Mamaya meron, hindi na natin nabutin yan. Meron kasing limits at infinity. Iba yon sa infinite limits. So, did I define it here? Hindi na. Okay. So anyway, a limit whose value is infinite. So let's consider this one. This is an example of an infinite limit. Consider this table here. So we will analyze the limit as x approaches 0 of the function 1 over x squared. So we will consider both directions, from the left and from the right. So we plug in 0.1, 0.01, 0.001, 0.0001 from the right, and then yung negative yung from the left. Negative 0.1, negative 0.001. So pinag-isa ko na lang because of the square here, magpapareho lang naman sila. So if you plug in plus or minus 0.1, you'll get 0.01. 1 divided by 0.01 is 100. You approach x, rather you approach 0, try a smaller value, 0.01, you get 10,000. Smaller value, 0.001, 1 million, and so on. And it is not hard to see that the smaller the value of x is, doesn't matter whether positively small or negatively small, you always have 1 over x squared getting larger and larger. The smaller the x is, the larger 1 over x squared is. So you can say that as x approaches 0, your function approaches positive infinity. And we state it as that. Limit as x approaches 0 of 1 over x squared equals positive infinity. And so we call this an infinite limit. And as mentioned, infinite limits may give rise to graphically vertical asymptotes. Look at the graph of f of x equals 1 over x squared. I-approach mo si 0 from the left. Hindi ko na pinakita yung buong graph kasi, sir, parang hindi naman lumalapit doon. Parang hindi naman yata nag-increase. It will increase without bounds. Actually, this is an asymptote. This vertical line, itong y-axis ito eh. Lalapit yung graph habang palapit pa ng palapit sa 0. But it never touches the line because it's approaching positively large values. Similarly, if you approach x0 from the right pala dito naman, your y values will just get bigger and bigger will approach positive infinity. So resulting again in an asymptote here. Okay? An asymptote, by the way, geometrically means position, or rather a geometric object, what do you call this, that the graph of the function gets closer and closer to. Okay? So actually, ang asymptotes, may kinalaman na sa limits yan. How do you get the vertical asymptotes? First, again, define muna natin. Okay? A line x equals c is called a vertical asymptote of a function if either, number one, limit from the left of the function as x approaches c from the left, is infinite, heading negative infinity or infinite positive. If not from the left, okay lang, as long as yung isang side nag-asymptotic siya. Limit as x approaches c from the right of f of x is infinite again. Heading negative, heading positive. And just set the denominator equal to 0 to get the vertical asymptotes. Napakadaling kuhanin. Medyo mas mahirap yung horizontal eh. Konti lang naman. Pero for the vertical, you see that when you are dividing by 0, it is not defined. And as you approach that point, you get positively large values or negatively large values. So you will have an infinite limit and thus a vertical asymptote at that point. So you know where to find them. You look at the denominator, you look at its zeros, find its zeros, but provided first, there's no cancelable factor, as I will illustrate in the next example. Okay, let's find the vertical asymptote of f of x equals x plus 2 over x squared minus 1. Look at the denominator. You equate it to 0. And you have two vertical asymptotes. By the way, you do not answer x equals plus minus 1. That is not a line. Okay? Or you do not just answer without the x. Sir, the vertical asymptotes are 1 and negative 1. Those are not lines. Those are numbers. So rather, you write the equations of the vertical lines. Namely, x equals 1. The graph of this is a vertical line. And x equals negative 1, also a vertical. And there. You see that the graph is asymptotic to those vertical lines. So later on, we will use vertical and horizontal asymptotes to guide us in the sketch of graphs. That's way, okay, after module 1. Sa module 3 yata yun. So after the derivative or module 4 na. Another example. How about this one? You might think that to get the vertical asymptotes, you just equate the denominator to 0 as done in the previous example, but no. You have to make sure there's no cancelable factor, but there is. So you cancel out the common factor first before you get the vertical asymptotes. So you're left with just 1 over x plus 1. So you equate now the denominator to 0. Makukuha mo na lang dahil ito na lang ang denominator, x equals negative 1, vertical line. It's this one. So by the way, because of the x being canceled out here, what this means is that there's a hole at negative 1, or rather at 0. Yung x over x. Diba? Ano yung zeros ng x? 0. So it's not defined at 0. So if you say, sir, another asymptote is x equals 0 because you equated this to 0, mali ka na. Walang asymptote na vertical dito. Only a hole there. That is why you have to first cancel out any common factor. Is there any question? We will just finish up to infinite limits. And by the way, kung napansin nyo na, medyo minug pa na yung quiz. The quiz is worth 10 points lang kasi nga yun ang binigay ng mga teachers, ng head teacher. And 3 questions only worth 10 points na answerable in 30 minutes. I gave already the schedule. You can view it in Canvas. Look at the reminders ba yan or wala sa announcements yon. Makikita nyo dun sa parang to-do ba yon ng part ng ano nyo, no, sa canvas nyo. So, nakalagay yung step. Feb 10 na. So, that's this Thursday. Just before the class ends. Still tentative. I might move it just at the beginning of class para hindi naman sumakit muna yung ulo nyo sa discussion. Kung may discussion pang kailangan, ano, unless natapos na natin ang module 1, syempre, it's assumed that we have finished module 1 by the way, before we have the quiz on that module. That means we will have the next module after the quiz if there's time left. An access code will be given and there will be a waiting room so that if you come in late, you won't know what the access code is. And hopefully I don't forget to notice who are still trying to gain admission to the Zoom session. Yeah, don't be late para ma-accept kita agad. And as soon as the quiz opens, you may start right away because you will strictly be given only 30 minutes to finish the quiz. Wala nang panugit. Okay. Next, to understand better the behavior of functions, we will study them near their vertical asymptotes. So kanina, na-compute na natin yung asymptotes nito, negative 1 and 1, we equated the denominator to 0. And we've seen the graph actually. Yan yan. So we will study numerically, not yet graphically, the behavior of the function near those vertical lines. Let's look at these tables. Those are the vertical asymptotes. Let's start with negative 1. That's a vertical line passing through negative 1 of the x-axis. So let's approach it from the left of negative 1. So we have negative 1.1, negative 1.01, and so on and so forth. Observe f of x, compute f of x, plug in negative 1.1 here. And so the others, and observe what's happening to f of x. This is on infinite limit. So either you will get negative infinity or positive infinity. Yun lang naman dalawang pagpipiliin. Wala namang 1/2 infinity, di ba? So you will just have to answer negative or positive infinity. So you're right. Limit as x approaches negative 1 from the left of the function x over x squared minus 1 equals negative infinity based on the table. Let's approach it from the right of negative 1 of this vertical aspect. So mag-start na tayo kung negative 1 from the right, ano na yon? Start ka na sa negative 0.9, negative 0.99, and so on. And compute, observe, getting larger positively, so conclude positive infinity, x approaches negative 1 from the right. Any question? Sir, what's the problem, sir? The quiz, siguro hindi nyo pa rin na, pansinin nyo yung syllabus, kada tapos ng bawat module, nakalagay doon, may quiz. So if it's quiz 2, that means the coverage of the quiz is the whole of module 2. If it's quiz 3, module. So we will have to finish the modules first before we have the quiz. So kaya tentative lang yung mga scheduling natin sa Canvas, pwedeng ma-move yun after, pwede pa ngang konti before. Kung merong 1 week at least in advance na may ano natin, ma-announce. Next. From the right na yung kabilang asymptote naman ang titignan natin. So yung kanina, ito, negative 1. There's another asymptote kasi, yun ang tanong, near its VA's vertical asymptotes. So we will have to, you will have, if this is a quiz, di ba? You will have to show another pair of tables for approaching 1 from the left and 1 from the right. Pakita ko ba dito? Hindi ko na yata napakita. So that will be your like practice, parang homework na hindi graded. I want you to show or verify that as x approaches 1 from the left, you have negative infinity, paki-practice, paggawa ka ng table na ginawa, kagaya ng ginawa ko dito, and then from the right, verify, pareho silang negative infinity, parang mali yata yung isa dito, no? Hindi, pareho, because, mali. I think this one from the left, yes. This should be positive infinity, typo siguro, kung talagang nagkamali ako. Mukhang positive infinity to. Paki-verify na lang. So graphically, ay iba pala ito no, sa kanina. Yung graph niya, no? So as you see, asymptotes, vertical asymptotes, later on when we go to sketching, you can use them as guides to sketch the graph near the asymptotes. So going back to the table here, for instance, this one, as x approaches -1 from the right of -1, it gets positively larger and larger. So ano ibig sabihin no? -1, tapos nanggagaling tayo sa right ng -1, umaakyat ka ng umaakyat kasi positive infinity. Now from the left, negative infinity siya. So it goes down. Gets closer, downwards, or towards, yes, in the downward direction, towards this vertical asymptote. So at least, vertical asymptotes will help us sketch the graph near the asymptotes. Okay, actually dito may horizontal asymptote eh. Saka dito, horizontal asymptote dyan. So once we have the asymptotes pa lang, pwede na, di ba? Tapos pagko-connect-connectin na lang natin sila. So that ends our discussion for today. Those who have any question regarding the discussion or kung may nagka-problema no, sa seat work, maling check, ganyan, hindi nakapag-seat work. I usually don't give, hindi ako required or hindi ako obligated magbigay ng make-up seat work. Make-up quiz lang, tsaka make-up long test. Pero subject to teacher discretion. The problem is, kapag pinagbigyan ko yung isa, baka sabihin unfair ako. So it's subject to the teacher's discretion. I hope you understand that. So if you have nothing to ask, you may leave the session. Others, you may stay. Hi sir, our quiz will be synced po. Ang seat work sync, pero ang quiz, teka. Hindi ako nagkakamali, ang quiz natin is not synchronous. Yes, class time, may time yon. Pwedeng class time yun eh, madalas class time. Hindi kayo required mag-connect sa Zoom, pero ang catch, ito, 3 questions yun, di ba? You cannot proceed to the next question if you haven't answered the previous question. If you cannot answer the previous one, you will have to give a no answer or just leave it so you can move on to the next question. This is to avoid also, you know, di ba, na cheating, right? And moreover, 3 questions only, and you have 30 minutes. So you have 10 minutes allowance for each question. And dito yung mga ka-level ng long tests. So, yun nga, hindi mo na pwedeng balikan once na sinagutan mo na ang isang item. Saka ka rin lang makakamove on sa next item kapag merong kang nag-click ka na ng submit sa previous item. So, pwedeng during sync classes yan, yes. Unless naubusan na tayo ng oras, gagawin natin outside class, may time pa rin na ibibigay, pero hindi na kayo naka-zoom. Hindi ko rin ipapa-record yung screen niyo. Ang recording ng screen, i-require kapag long test na, pero hindi rin naka-zoom tayo. Nag-zoom lang tayo kapag seat work at binibigay lang ang seat work during class hours. So pag na-miss mo, walang make-up dapat. Yung seat work ha. So you may stay if you have a question. Yes, seat works are graded 20 points in all pa rin yun out of the 500 o 400. So parang maliit lang, pero sayang. Minsan yun ang nagde-determine ng grade mo. Halimbawa, 3 points na lang kailangan mo to get the next letter grade tapos hindi ka nakapag-quiz ng dalawa, di ba? Apektuhan pa rin. If you have any question regarding anything, you can just consult the syllabus. And those who want to question me regarding the missed seat work, you can stay. The rest may go.
Thank you, sir.
Thank you, sir.
Written and scanned or ano yun? Depende kasi yon. Usually kapag quizzes, multiple choice, true or false, and minsan din naman yes. Magpapa-file upload ako, so it could be handwritten. Handwritten and then you have to scan it or take a picture using your cell phone. Upload pa sa Canvas. Mr. Roque. Yes, those who remained, stayed, may tanong ba kayo? Can unmute your microphone.
Hello, sir.
Teka. Stop share. Yes, Mr. Oh, who's fake?
Lorenzo Ku, sir.
Yes, Mr. Ku.
For seat work 1.
Okay. How about Miss Zafra?
Me too, sir. Seat work 1.
Miss Moren. Okay.
Yes.
I will only allow you this time, alright? Not next time, wala na ha?
Okay.
Now, you submit via email kasi hindi ko kayo pwedeng baguhin pa yung setting ng para sa grading kasi yon maapektuhan. So, I will give you, ano na ngayon? 3:18. So, kasi 5 minutes yun eh. So, hanggang 3:25 essay to. Please, can you please define what an indeterminate form is? You may leave, pero isasabit nyo before 3:25 yun sa email. Okay? What is an indeterminate form? Yun lang.
Thank you.
Thank you, sir.